Hello hunters, today we're going to dissect the LimeRat sample. In this case, we'll use a few tools which help us understand the malware better. Here we go. Let's start with opening a sample in the DetectItEasy program. It is written on visualbasic.net. Now we go to DNSpy. Here are the classes of name, methods, and variables that are impossible to read, so we can assume that malware uses obfuscation. Okay. Let's try to find a class with malware configuration. And I think we found it. Look at this line. It seems like base 64. Let's try to analyze it. There are two methods that refer to the line. The first method isn't interesting to us, but the second one is different. Using a web client, the program downloads the decrypted content in this string. And we can see the decryption algorithm. Let's break it down. At first, an instance of the LimeRat managed class is created. Then, it follows that the AES algorithm is used for the encryption. After an array of 32 bytes is allocated, MD5 algorithm generates hash sums based on the string of the configuration class. In the next step, the first 16 bytes of the generated hash are copied to the previously initialized array, and in addition, another 15 bytes of the hash are copied, and the last element of the array remains 0. The resulting array is being set as the decryption key for the LimeRat managed class instance, and the AES mode is set to ECB. Then we can decode the encrypted string from base 64 and decrypt the decoded string. Let's repeat it in CyberChef. For that, we have to open two tabs of CyberChef. This one is to generate the key, and the second one is to decrypt the data. I'm copying this weird string and adding it to CyberChef. And if I chose base 64, only gibberish comes up. Let's try to generate the key on our own and decrypt it. Then we're copying the string, and on its basis, we will generate the key and apply the MD5 algorithm. Press Ctrl+C for 15 bytes of the hash and find the AES algorithm. Set the ECB mode and put input in raw mode. Paste these 15 bytes of the hash and copy-paste additional 16 bytes. And as the array was initialized of zeros, let's add another 0. Okay, now we can see a note. Let's open it in a separate tab, and it seems pretty unusual. Go back to DNSpy and find the note in the code. Here we see that the uploaded note is split by a colon. Then the program selects a port randomly and makes an attempt to connect to the C2 server. Let's move to ANY.RUN Interactive Sandbox and carry on dynamic analysis of the sample. The first step is to create a new task, upload a file to the service, and run it. We're waiting for a little bit to get the first results. That's it. Let's look closely at the running processes. There's a process with winlogon.exe name. We've seen this name before in the string with the configuration class. So now it's clear that its field is responsible for the name with which the malware process will be restarted. Back to ANY.RUN. Just 20 seconds since the task's beginning, and we already see the extracted malware configuration. Dive in to find out what a configuration class's field is responsible for. Now, let's check the network activity. It shows us that an established connection with pastebin.com and the malware has got the data from there. They're equal to the results of static analysis. Now let's move on to the connections. Here we observe that LimeRat has established a TCP connection with the C2 server and is starting a data exchange. Thanks to the detailed malware configuration of ANY.RUN, we know which delimiters the malware is using, and we can try to decrypt the traffic. We're copying the package contents to CyberChef and seeing a decrypted fragment of traffic with sensitive data. We've done all that we planned and can stop the task. You can get an HTML report with a comprehensive summary of the malicious behavior, including the malware configuration. There is also a task's video recording, a process tree, file operations, registry activity, HTTP request registry, and so on. As you can see, it takes only 40 seconds to get a lot of information about malware samples from ANY.RUN and even decode encrypted stolen data. Now the service is available with more than 40 types of malware configurations, which helps analytics get info quickly and productively. This feature is free and available for every user's plan. Thank you for watching this video and good luck with your malware hunt.